0 marks. That is exactly what the examiner's red pen just gave to a flawlessly calculated physics problem. Why? Because of a single invisible trap hidden right in the command words of your IGCSE Physics 0625 paper. We are going to completely bypass the hidden grading traps that are literally destroying top grades. Let's get straight into it.
So what is this invisible calculation trap that's costing you a top grade? Picture this. You're sitting in the exam hall. You've just spent 3 agonizing minutes under severe pressure calculating a really complex resultant force, or maybe an incredibly short time interval. You finish the math, you write down the number 4. It is perfect, mathematically flawless. But the examiner gives it a flat 0. Why on earth would they do that? Well, because you left off the SI unit, or maybe you just missed a simple metric prefix. Here's the harsh truth for physics. Numbers without units are completely meaningless. We use numbers and units together to describe space and time, and examiners show absolutely zero mercy if you forget them.
Think about a passenger jet's flight deck for a second. The instruments in that cockpit give the crew life-or-death information about the plane's performance. Just like absolute precision with those instruments dictates the survival of everyone on board, absolute precision with your SI units determines your exam survival. Before you can even make a measurement, you have to choose a standard, a unit. If a pilot misread a unit on a dial, it would be an absolute disaster. If you misread a unit in a question or forget to write one down in your answer, well, that's a crossed-out answer and a lost mark.
And the cost of this mistake is huge. The 3 basic quantities we measure all the time in physics are length, mass, and time, right? Almost all other units are built entirely off of those. So when you fail to use the proper standard units for these fundamental quantities, you aren't just losing a tiny fraction of a mark. Oh no, you are dropping full method marks. The error cascades through the rest of your multi-step calculation, and it completely shatters your grade boundaries.
Section 1. Why ordinary revision fails.
You might be thinking, hey, I read the textbook, I memorized my formulas, this isn't going to happen to me. Well, let me share the examiner's red pen hit list. This isn't just guesswork. This is exactly what they're actively hunting for to deduct your marks. We're talking about missing units, obviously, but also rounding your numbers way too early in a multi-step calculation, or giving super vague explanations for practical improvements, or plotting the wrong variables on your graph axes, and writing conclusions that literally aren't supported by the data you just collected. These are the most painful yet common mistakes students make, especially when you're asked to describe how to measure length, volume, or time intervals using basic devices. To dodge that red pen, you absolutely have to master the SI system, the Standard International System of Units. It's a decimal system, meaning units are divided or multiplied by 10 to give smaller or larger units. Let's look at standard form, or powers of 10 shorthand, because examiners absolutely love this. Instead of writing out a huge, messy number like 4,000, you write 4 times 10 to the power of 3. See how it scales? 400 is 4 times 10 to the 2. And it works for tiny measurements too. 0.004 is written as 4 divided by 1,000, or 4 times 10 to the negative 3. They expect you to use this neat shorthand. It proves you understand metric prefixes, and most importantly, it stops you from accidentally dropping a 0 in a rush and tanking your whole calculation. Speaking of tanking an answer, let's look at another classic trap, scalar versus vector quantities. You know this, right? A scalar quantity has magnitude, which just means size. That's it. But a vector quantity, that has magnitude and direction. Force, velocity, those are vectors. Here is the trap. If an exam question asks you to calculate the resultant of 2 perpendicular vectors, and you only give the size but completely ignore the direction, that's a fatal error. You have got to take their directions into account to combine them properly. Now, in just a moment, I'm going to reveal the exact examiner clue that completely changes your final calculation. But before we get to that clue, you need the framework that actually makes it obvious. You really don't want to skip this next part. Section 2. The Ultimate Answer Framework. Okay, this is the elite 4-step Cambridge framework. It is designed to totally bulletproof your answers. It takes your raw physics knowledge and shapes it into exactly what the mark scheme is begging for. Step 1 is concept. Ask yourself, what fundamental physics principle is actually being tested here? Step 2 is evidence or data. What specific numbers, graphs, or pieces of apparatus are you pulling from the prompt? Step 3 is scientific reasoning. How do the data and the concept logically connect? And finally, step 4, examiner wording. Are you actually fulfilling the exact command words using exam-safe terminology? If you link your theory directly to the data and use specific wording following this exact flow, you're locking in that top band mark every single time.
Section 3. The Spot the Error Challenge.
All right, put yourself in the examiner's seat for a second. Let's compare a flawed, panic-induced student response to a top-band one. Can you spot the fatal flaws in the first one? They rounded their numbers way too early in the middle of the calculation, which completely threw off the final result. And to make matters worse, they forgot the final units. Bam, 0 marks. Now look at the top-band answer. See the difference? This student substituted their values correctly. They included the correct SI units at every single necessary step, and they matched their final answer to the correct significant figures. They didn't just do the math, they completely satisfied the command words using our framework.
Let's apply this with a rapid, high-value practical tip straight from the syllabus. Exam check time. Listen closely. Any single measurement you make is not going to be entirely accurate. It will always have some error associated with it. But we need accurate measurements for practical work. So, to shrink the size of that error, you must take the average of several measurements, or measure multiples. This is absolutely critical when you're trying to find the average value for a tiny distance or a super short time interval. Memorize this exact concept to secure those practical marks.
Section 4. Your mandatory next step.
So, we've covered the unit traps, scalars, and the framework. But honestly, fixing your units and significant figures is really only half the battle. Think about it. How do you actually structure this perfect, framework-driven answer under severe exam time pressure? A flawless calculation with perfect units means absolutely nothing if the clock runs out before you finish the last page of the paper. This timing trap is the second massive hurdle standing between you and that top grade, and you need a specialized system to beat it.
You absolutely have to master a timed answer writing system to truly conquer Cambridge physics. Ask yourself, are you losing easy marks not because you don't know the physics, but simply because you don't know the clock? Our next explainer gives you that exact system, and it is the ultimate lifeline for your final grade. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. See you in the next one.